Okay, let's take a look at another practice problem for these one-dimensional motion issues. So here we have a bullet. It's traveling at 800 meters per second, strikes a tree, passes through the trunk, emerges at 500 meters per second. The diameter of the trunk is 30 centimeters. We would like to know the acceleration of the bullet inside the tree trunk and how long the bullet was inside the tree. Pause the video, work the solution. Okay, so we will employ our problem solving strategy. Let's list our variables. We know that the variables to be considered are the initial velocity, final velocity, acceleration, time, and displacement. We will need to make our units consistent, and in this problem we have meters per second, and centimeters. These units are not consistent. 30 centimeters is 0.3 meters. So we're going to need to use that. So the bullet's moving at 800 meters per second. And when it emerges from the tree, it has a velocity of 500 meters per second. And the tree trunk is 30 centimeters thick. So we're only evaluating the motion of the bullet inside that 0.3 meter displacement. So while it's inside the tree, 0.3 meters. Okay, let's find the acceleration. We know our equations of motion. V is V naught plus AT. V average is V plus V naught over 2. X is V naught T plus a half AT squared. And V squared is V naught squared plus 2AX. All right, we need to select an equation. So let's see if we can find this acceleration. We need an equation with acceleration, and we need to know all the other variables. So it looks like the first equation and the last two. Okay, so let's look at the first one. We do know V naught. We do know V. We don't know the time, so the first equation won't work for us. The quadratic, this one, looks like, again, we don't know t, so that's not going to work for us. Last equation, we know v, we know v naught, we know x, and most of us can handle the number 2. So let's use this equation and solve for the acceleration. If v squared is v naught squared plus 2ax, and I manipulate this equation to solve for a, v squared minus v naught squared over 2x. The final velocity is 500. We'll square that. The initial velocity was 800 squared. This is 2, and our displacement is 0.3 meters. We toss this in our calculator. Let's see. Looks like something on the order of negative 650,000 meters per second squared, or negative 6.5 times 10 to the 5 meters per second squared. Okay, that takes care of the acceleration. That is a very large acceleration. Okay, so that's part A. And for part B, we want the time. So let's figure out how long this bullet is inside the tree trunk. guys, if I want to solve for time, I know every other variable, any equation with a t will work. I can solve this one for t, but why do that with a quadratic when the first equation is so beautiful? So on the first equation, if I manipulate this equation to solve for t, I'll see that t is v minus v naught over a. That's 500 minus 800 over negative 6.5 times 10 to the 5. Looks like negative 300 over negative 6.5 times 10 to the 5. This is not going to be a long period of time. Yeah, it looks like a very short period of time. 4.62 times 10 to the negative 4 seconds. It's a very short period of time, which we would expect for a bullet passing through a tree. So that'll work. Guys, if you ever solve one of these and you get negative time, something has gone wrong. You might want to take a look at that. Negative time would be an unusual situation. So that's the first example. Now let's take a look at one more. Okay, so this one's going to be a little bit different. Okay, so here we have a child on in a wagon. Child starts from rest at the top of this slope, accelerates at 1.6 meters per second squared down the slope. We want to know what's the velocity of the wagon at the bottom of the slope and how long it takes the wagon to reach the bottom of the slope once it begins moving. So pause the video and attempt the solution. Okay. Problem solving strategy. List your variables. Are our units consistent? We have, let's see, looks like the height of this wagon above the bottom of the hill is 20 meters. Acceleration is in meters per second squared, so we're going to look okay for our units. The problem does state that the wagon starts from rest. So that's 0 meters per second for V naught. The acceleration is given as 1.6 meters per second squared. And it looks like that's all we have, but I believe we also know the displacement. Part A wants to know the velocity at the bottom of the slope. And part B wants to know the elapsed time. So it looks like we're dead in the water without the displacement. But if you look at the slope, the displacement is the distance down the slope. And that's just the hypotenuse of a right triangle. So we have a triangle where we know the angle is 20 degrees and the side opposite the angle is 20 meters. So solve for the hypotenuse. Opposite and hypotenuse, that's a sine function. So if the sine of the angle is opposite over hypotenuse, then hypotenuse is opposite over the sine of the angle. 20 over the sine 20 degrees. And It looks like 58.448 meters, somewhere in that ballpark. So 58.48 meters. Now, if you put that in your calculator the way that I have it written, and you get a different value, you may want to make sure that your calculator mode is degrees and not radians. Make sure that you are in degrees mode. All right, so 58.48, and now we're ready. So from our equations, okay, well, if I want to solve for V, let's check the first equation. We know V naught, we know A, we don't know T. Let's check the second equation. We know V naught, we know A, we know the displacement. So it looks like we have a winner with our second equation. Not a great deal of manipulation is necessary. So for this equation, V is the square root of V naught squared plus 2ax. That's simply manipulating this second equation to solve for V. The initial velocity, well, the child started from rest, so this V naught term is a 0. So all we need to do is radical 2 acceleration displacement to 1.6, let's see, 58.48. Let's see what we get here. Yeah, this looks like about 13.68 meters per second or so. That's going to be our velocity at the bottom of the slope. Yeah, guys, just for future reference, that's about, it looks like about 30 miles per hour. This kid is a crazy kid. Probably going to get hurt. 30 miles an hour in a wagon's unbelievable. So now let's solve for T. If I want the time, looks like the first equation is going to be plenty because I know all the other variables. So if I manipulate this to solve for the time, V minus V naught over A, so 13.68 minus 0 for the initial velocity. Acceleration is 1.6. And this looks like about 8.55 or so, say, somewhere around in that ballpark. So 8.55 seconds. There is our solution.